Hi everybody, let's look at number 4 from section 2.6. A projectile is fired from a cliff 200 feet above the water at an inclination of 45 degrees to the horizontal, with a muzzle velocity of 50 feet per second. The height h of the projectile above the water is given by h of x equals negative 32x squared divided by 50 squared plus x plus 200, where x is the horizontal distance of the projectile from the base of the cliff. We want to know how far from the base of the cliff is the height of the projectile maximum. We want to find the maximum height of the projectile. How far from the base of the cliff will the projectile strike the water? We'll graph h of x on the domain 0 to 200 inclusive in Desmos, and we'll look at the height of the projectile. We want to see when the height of the projectile is 100 feet above the water, and how far is that from the cliff. So when we're looking at this problem, it's a little helpful to consider a picture. Here's our cliff. It's 200 feet high. And the part that reads the projectile is fired at an inclination of 45 degrees to the horizontal means we're at the top of the cliff, and this is the horizontal, and so the 45 degrees will be here. And so what this is telling us is that when the projectile is launched, it's going to go at a muzzle velocity of 50 feet per second. So it's going to go up and then back down. It's going to finish off over here as well, but we're not interested on that as a part of the curve. The x and y axis would be right here. So the y-axis is going to be the edge of the cliff, and the x-axis will be when the projectile hits the water. So when we look at part A, we want to know how far from the base of the cliff is the height of the projectile maximum. Okay, so when we look at the projectile maximum in the quadratic, that's going to occur at the vertex. And in this instance, we want to know how far from the base of the cliff. So for part A, we want to know the x-coordinate of the vertex. That is, when is x equal negative b over 2a. So it might be helpful to clean this part up a little bit. So we have negative 32 over 50 squared, which is 2500. When we can divide the top and bottom by 4, and we'll get negative 8 over 625. This means we can write h of x as negative 8 over 625 x squared plus x plus 200. So when we find the x-coordinate of the vertex, we'll have negative, the b is 1, and then divided by 2a, so negative 8 over 625. So the negatives will cancel, and we'll get 1 over 16 over 625, and when we take the reciprocal of that, we'll get 625 over 8 over 16, and this is approximately 39 feet. For part B, we want to know, find the maximum height of the projectile. So that means we want to know the y-coordinate of the vertex, which means we'll find h of 39. And so we'll plug in 39 in for x. So we'll have negative 8 over 625 times 39 squared plus 39 plus 200. And when we bust out our calculators, I'm getting approximately 219.5 feet. Okay, so let's look at part C. And so we wanted to see in part C, how far from the base of the cliff will the projectile strike the water? And so we want to know how far from the base of the cliff. So we're looking for the x coordinates here. And so my question to you is, what number will the height be when it strikes the water? And this will be when h of x equals 0. So that's what we'll solve for part C. We're going to plug in our function here and set it equal to 0. So for part C, we're going to have negative 8 over 625 x squared plus x plus 200 equal 0. We'll use the quadratic formula on this, so x will equal negative 1 plus or minus the square root of 1 squared minus 4 times negative 8 over 625 times 200. And that's a 2. And then all divided by 2a. 2 times negative 8 over 625. Alright, so I'm using my calculator for this. I'm going to get approximately 170 and negative 91.9. So the answer that's going to make sense is the 170 feet. The object will strike the water 170 feet from the base of the cliff. So for part D, we're going to go to Desmos. I already graphed it here. And so the great thing that we can see is that you can kind of check your answers. So there's the vertex. Here's the answer we just found. And when you look at part E, we wanted to know how far from the base of the cliff is the object 100 feet up. And so that's going to look like about 135.6. So let's go back to our work to figure out how to do that. All right, so for part E, we want to know when the height of the projectile is 100 feet. So we're solving h of x equals 100. This means we'll have negative 8 over 625 x squared plus x plus 200 equals 100. To solve this quadratic equation, we'll subtract 100 to both sides. So we'll have negative 8 over 625 x squared plus x plus 100 equals 0. So then again, we'll use the quadratic formula. X equals negative 1 plus or minus the square root of 1 squared minus 4 times a times c. All over 2 times negative 8 over 625. And then again, using our calculators, we'll approximately come up with 100 135.7 and negative 57.5. And again, it's going to be the positive, so the answer is going to be 135.77 feet. So when the object's 100 feet in the air, it's 100. The distance from the cliff is 135.7 feet. All right, everybody. Hope you found this problem helpful, and I'll see you in the next video.